Welcome to Formula 1 Maths. This is lesson 5.3 for GCE A-Level Applied Maths, Year 2. In this lesson, we are going to explore the meaning of friction and learn to solve questions involving friction. Friction is defined as a force acting between two rough surfaces which opposes or prevents relative motion between the surfaces. Consider a block of mass m resting on a rough surface. This means it will exert a weight of mg on the rough surface. And according to Newton's third law, the rough surface will also exert a reaction force of R on the block. At this point, there's no movement between the block and the surface. So there's no friction acting at all. But when a force, F, is applied to the block, then friction is generated between the block and the surface. The block will not move until the force F is big enough to overcome a certain maximum value of friction, also known as limiting value of friction. So when F is big enough to overcome F max, then the block will start moving. This limiting value of friction depends on two factors. One, the normal reaction force acting on the block, which is also, according to Newton's third law, is an indication of how heavy the block is. Two, the coefficient of friction between the block and the rough surface. The coefficient of friction is a measure of the degree of roughness between the two surfaces. And this is denoted by the Greek letter mu. This means that a heavy block will have a higher F max than a lighter one. Again, according to Newton's third law. Please note also that mu ranges between 0 and 1. For a smooth plane, mu is equal to 0, and mu will increase as the degree of roughness increases. At this point, we are going to answer two questions involving friction. Question 1. A block of mass, 5 kilograms, is placed on a rough plane which is inclined to the horizontal at an angle theta, where tan theta is equal to 4/3. The coefficient of friction between the block and the plane is 1/3. The block is released from rest. Find the acceleration of the block. So we need to sketch. And we have a situation like this. So this is a plane. And it's inclined at an angle theta to the horizontal. We need to put our forces, the forces acting on the block in. So first we have a reaction force, which is perpendicular to the plane. Then because the block is moving down the plane, or will move down the plane, the frictional force will act in the opposite direction. Then we have a 5g Newton weight acting vertically. We do not need to resolve the reaction force because it's perpendicular to the plane. And we do not need to resolve the frictional force because it's parallel to the plane or along the plane. But we need to resolve the weight into two components, one perpendicular and the other one along the plane or parallel to the plane. We know that this angle here is 30 degrees. And that makes this component 5g cos theta and the other component 5g sin theta. We will now draw a right angle triangle with the angle in place as shown in the diagram over here. And because we are told that tan theta is equal to 4/3, that makes this length 4 and our length 3. And using Pythagoras theorem, the hypotenuse becomes 5. We are now in a position to write down the values of sine theta and cos theta. So sine theta will be 4 over 5 according to SOHCAHTOA, and cos theta will be 3 over 5. We also know that mu is 1/3. F is equal to mu times r. But because the block is not flying off the plane or moving through the plane, we can say that r is equal to 5g, since they act in opposite direction. So r becomes 5g cos theta. But cos theta is 3 over 5. So we substitute and then reduce the fractions by cancelling out 5 here 1, 5 there 1, 3 here 1, 3 there 1, and that's how we end with G newtons as our friction. Then we go to use Newton's second law, which says F equals to ma. The resultant force, that is bringing down the block, will be 5g sine theta minus the frictional force. If we evaluate that, we have 5g sine theta minus g, as we found out here. And then we substitute these values in our equation here, F equals to ma, and we get this. Now we can substitute the value for sine theta to get this, and then we can simplify that to get 4g minus g equals to 5a, because we can cancel this one, and cancel this one, here. So this simplifies to 3g is equals to 5a, and then a will be 3g over 5 meters per second squared. Evaluate it, and we are going to get 5.8 meters per second squared. And so that's the acceleration of the block. Question 2. A block of mass 5 kilograms is moving up a fixed plane at a constant speed of 20 meters per second under the action of a force of magnitude 40 newtons. The plane is inclined at 30 degrees to the horizontal. The force acts in the vertical plane containing the line of greatest slope of the plane through Q, and acts at 30 degrees to the inclined plane, as shown in figure 1. The coefficient of friction between Q and the plane is mu. Find A, the magnitude of the normal reaction between Q and the plane. B, the value of mu. For C, it says the force of magnitude 40 newtons is removed. Find the distance that Q travels between the instant when the force is removed and the instant when it comes to rest. So, we need to put in our forces that are not already on the diagram. First, we have the weight of 5g acting vertically. We have the reaction force R acting perpendicular to the plane. And we've got a frictional force opposing the motion and therefore acting in the opposite direction. We don't need to resolve the reaction force because it's already perpendicular to the plane. And we don't need to resolve the frictional force because it's parallel to the plane. But we will need to resolve the weight and the 40 Newton force. For the weight, we resolve into two components, one perpendicular to the plane and the other parallel to the plane. We know this angle here is 30. So that means this component is 5g cos 30. And this component will be 5g sin 30. Now we turn our attention to the 40 Newton force, which resolves into 40 cos 30 parallel to the plane and 40 sin 30 perpendicular to the plane. For A, we consider the force is perpendicular to the plane. So in that case, we have R plus 40 sine 30, because they are moving up, must be equal to the only force which is perpendicular and moving down. And so we get this equation here. If we rearrange, we're going to get 5g cos 30 minus 40 sine 30. And we evaluate this to get 22.4 newtons. And that is the value for the normal reaction force. For B, we consider the forces parallel to the plane. Because the body is moving with a constant velocity or a constant speed, we can say that there will be no acceleration at all. And that means the forces going this way will be equal to the forces going that way. So F plus 5g sine theta, this one, must be equal to 40 cos 30, which is going in the opposite direction. We can rearrange to find F, which will be 40 cos 30 minus 5g sine 30. But we also know that F is equal to mu r. This implies that mu is equal to F over r. But we have the values for both F and r, so we go to substitute together. So the value of F is what we found here, and the value for r is what we found here. So when we do a substitution, we can evaluate this to get mu is equal to 0.45 to two significant figures. Question 2c. The force is removed. And when the force is removed, the dynamics of the block changes completely. And using the word dynamics here is not just a cliche. The dynamics of the block has changed for real because there's a new motion. Because for now, the block is going to decelerate, and that's why it will come to rest. So let's put in our forces. So here we have 5g, the weight is still acting. We have a normal reaction force, R1, a frictional force, still acting that way. We do not need to resolve the normal reaction force and the frictional force, but we do need to resolve the weight. So if we do that, we get this. And now we can solve our question. So like I mentioned earlier, the dynamics of the particle has changed. There's a new motion which starts from the point the force was removed. And in that case, the initial velocity will be 20 meters per second. The final velocity will be when it comes to rest, and that will be 0. So we have these conditions here. So u will be 20 meters per second. Our v will be equal to 0. S is the value we need to find, and we've got enough information to find the acceleration. So we can now go and use Newton's second law to find the acceleration. So F equals to ma, and taking the positive direction to be the direction upward, the plane, we can say the force opposing the motion and which will ultimately bring the block to rest will be F1 plus 5g sine 30. And because of the direction, it is negative. So this one here is our big F over there. And our mass, as we know, is 5. And we can now find acceleration here. And this acceleration is for this particular motion, new motion, that started when the force was removed. So we need to find F1. But F1, we know, is equal to mu times R1. And because the surface has not changed, mu is the same as we had in the previous question. And also, R now has changed and it's only equal to 5g cos 30. So if we do a substitution, we have 0.52, which is mu, times R1, which is 5g cos 30. So therefore, coming back here and doing our substitution, we get 5a is equal to all that. We can now divide every term by 5, factorize out the g together, and then we do our calculation and we get minus 8.74 as the deceleration. So we now have information to calculate s, the distance moved, using this information right here. So the Stewart equation that comes to mind is v squared is equal to u squared plus 2as. Doing our substitution will give us 0 is equal to 20 squared minus 2 times 8.74s. Rearrange to get 17.48s equals to 20 squared. Divide and solve for s to get this. Evaluate to get 22.9 meters. And this is the distance that the block will move before it comes to rest. So this is the end of lesson 5.3. So thank you again for watching, and I'll see you in the next video.